In this section, we're going to talk about a specific type of chemical reaction known as acid-base reactions. Acid-base reactions are a special type of double replacement reaction. In an acid-base reaction, acids undergo dissociation in water, releasing a characteristic hydrogen H+ ion, and bases in water undergo dissociation, releasing a characteristic OH- hydroxide ion. This reaction is also known as a neutralization reaction because these two ions, the H+ and OH-, combine to form water. In this case, instead of forming a solid precipitate, which is what we would expect from the double replacement reactions that we've seen in another section, the result of the neutralization reaction is to form water. Let's spend a couple of slides now talking more about acids in detail. Acids are capable of releasing at least one hydrogen ion in aqueous solution. Remember that means dissolved in water. There are some acids that can provide more than one, and we can recognize acids from their chemical formula because all common acids have a chemical formula starting with H. So here is a list of some where you can see that preceding H, HCl, HBr, HI, HNO3, those all have one hydrogen that they can provide. But then look, this next one, H2SO4, has two hydrogens, and this last one, H3PO4, has three hydrogens. Shown below is a list of common acids with their names and formulas. So some of the ones that you might be most familiar with: hydrochloric acid is HCl, maybe nitric acid, HNO3, sulfuric acid, H2SO4, phosphoric acid, H3PO4, vinegar, or also known as acetic acid, HC2H3O2. So here's a list of the common ones that you might see throughout your practice problems and other examples. Okay, we've talked a couple slides about acids, now some more details about bases. All bases are capable of releasing at least one hydroxide ion, OH-, in aqueous solution. So when dissolved in water, bases will release at least one hydroxide ion. Some will provide more than one. Bases are ionic compounds with hydroxide ion, OH- as the anion. The majority of bases are derived from the first group of alkali metals and the second group of alkaline earth metals. So we can see the group 1 examples here: lithium, sodium, potassium, rubidium hydroxide, and they all have one hydroxide ion that they can provide. And the group 2 bases, magnesium and calcium hydroxide, you can see that they have two hydroxide ions. Okay, so what happens when an acid-base reaction occurs? An acid-base reaction involves the reaction of an acid. On the left, we have HCl, aqueous. So we have a hydrochloric acid dissolved in water, sodium chloride, aqueous, dissolved here. So we have an acid solution and a base solution. When we mix them together, we get this product, which is an ionic salt. So we have sodium chloride, but it's soluble in water, so we write aqueous, and liquid water. So an ionic salt and water. The ionic salts produced in the majority of acid-base reactions are water soluble, so you won't see the formation of a precipitate in your product. Salts, though, containing sodium, potassium, ammonium, and nitrates are soluble. Okay, those will always be aqueous in solution, no precipitate, but some carbonates, sulfates, and phosphates are insoluble. When the reaction occurs, the ions appear to switch places with each other, as in precipitation reactions that we've seen. So this H is now with this OH, and this Na is now with the Cl. So we have NaCl and water. The bond between H plus and Cl breaks, and the H plus bonds with OH, which is what we see in the formation of water. The bond between Na plus and OH minus breaks, and Na plus bonds with Cl minus. That's how we get this product here. But the product, NaCl, is soluble in water. Recall back to your solubility rules. And so we end up with a clear solution where NaCl is aqueous in liquid water. Here are some examples of acid-base reactions, and in all three cases, the chemical bonds on the left are broken and reform to produce the products on the right in the form of an ionic salt and water. So we have the acid HNO3, the base KOH, those bonds break, and we form K with nitrate NO3, KNO3, and water, magnesium and sulfate, SO4, form MgSO4, and then we get waters, two waters. That would make sense because we have two H's and two OH's, so to balance it, we would need two H2O's. And then H3PO4 and LiOH. So Li would reform a bond with PO4, and then these H's would form a bond with these OH's. And you have to be careful because these salts are ionic, so you need to remember to write their formulas according to how you write ionic formulas. So lithium ions are +1, phosphate PO4 is -3, so we have to have 3 positive lithiums for 1 3- phosphate. We get Li3PO4. Okay. All right, over the next several slides, we're going to go over this example for an acid-base reaction. So predict the products for the reaction between hydrobromic acid, HBr, and calcium hydroxide, CaOH2. So we know that these are aqueous in solution, right? They dissolve in solution to H plus, Br minus, Ca2 plus, and OH minus, right? Have our ions in solution, and the H plus and the OH minus ions form water, right? So one of our products needs to be water, and the other product is formed between calcium 2 plus and Br minus. So keeping in mind our charges, then we get CaBr2. Okay. All right. Okay, so what we see right here is exactly what we wrote down on our previous slide. Number 2, though, says put the phases of the products and balance the equation. So we know that water is a liquid and calcium bromide is not insoluble, so it would be aqueous. And then we need to balance. So I think, let's see, we're going to need 2 HBRs to balance the bromines on the right, and then the last thing we need is 2 waters. So we'll move ahead a slide and confirm that. But I think our coefficients here are 2, 1, 1, 2. Calcium bromide is aqueous, water is liquid. Okay, so just as we have our coefficients 2, 1, 1, 2, 1 OH minus ion is needed for each H plus ion. Okay, and then just as we said, calcium bromide aqueous, water liquid. The last question we need to answer is, will this reaction proceed? So just like in our double replacement reactions, we ask the question, will this reaction proceed? So the answer to the question, will this reaction proceed, is yes. All acid-base reactions occur. So it's different from a double replacement reaction where you have to have a solid precipitate for the reaction to occur. If we have this water and this ionic salt as a product, that's a neutralization reaction, and that always occurs. All right, let's walk through one more example together before we do any formative assessment questions. Predict the products of the reaction between sulfuric acid and sodium hydroxide, H2SO4 and NaOH. So we know that basically we switch places here, right? The H goes with the OH and the Na goes with the SO4, but we just have to be careful of our ionic salt because Na is plus and SO4 is 2 minus. So we would produce Na2SO4, an ionic salt, plus water. All right, so we can see our products here, Na2SO4 plus water, match what we predicted on the previous slide. Now let's put in the phases of the product and balance. So Na2SO4, remember any group 1 metal is soluble, so this is going to be aqueous. And water is going to be a liquid. And then we need to balance. So on the left, we only have 1 sodium, and on the right, we have 2. So we're going to need to take care of that. We need 2 sodiums. And then we have 1 SO4 on each side, so that's okay. Let's make sure our hydrogens and oxygens are balanced. So we have 1, 2, 3, 4 hydrogens and 2 oxygens. So we can balance that with our waters here. We put a 2 there, that'll give us 4 hydrogens and 2 oxygens. Okay, so 1, 2, 1, 2 are our coefficients. Na2SO4 is aqueous, H2O is liquid. Okay, this slide confirms that answer. Our coefficients are 1, 2, 1, 2, aqueous and liquid or aqueous. For each sulfuric acid right here that releases 2 hydrogen ions, we would need 2 NaOHs to release 2 OH minus ions, essentially making sure we have an equal number of water molecules. And then the last question, will this reaction proceed? And the answer is yes, all acid-base reactions occur. It's a neutralization reaction, no need for a formation of a precipitate, it will occur.